And welcome back, everyone. In this video, we're going to be talking about system development life cycles, or software development life cycles, depending on what you believe the S is in the acronym. I've heard it said both ways. You Google Sdlc, you're going to see it both ways, written both ways. So, yeah. Basically, Sdlcs are structures, and the certain types of structures depend on what type of thing you have. So let me put it this way. You don't always have the exact same concept for every single thing. The task at hand determines what you're going to be using. You're not going to have the exact same structure for writing a book report that you would for, working out at the gym. It's not the same thing. One is in theory an endless process. The other one is, you write it once and you're done. So, here's what this is. I'll start with the simplest one, where I'm just going to click here and, boop, and I'll just drag this down here. We've got ourselves step 1, step 2, step 3, and in theory, step 4, step 5, step 6, so on and so forth. This is what is known as the Waterfall Model of Sdlc. We have ourselves step 1, step 2, step 3. This is your book report. You have yourselves your planning phase, your brainstorming. And then you have over here, your rough draft. And then over here you have your edits. And then of course, I'll just make another step like this. And boom, and we have ourselves our final. Okay? Step 1, step 2, step 3, step 4. After we make our final draft, we don't go back up to the rough draft. That doesn't make any sense. We don't go back up to planning. It's already done. It's final. There's no circulation here. There's nothing like this. It's step 1, step 2, step 3. Now, I want to just take a step back and think about this for a moment. What could be a good potential situation where you would do something like this? Well, book report, obviously. Now, is this something simple? Step 1, step 2, step 3, step 4. Yes. Yes, it is. Question, is this something that's a good idea to use if, this is a multi-bajillion-dollar project? Probably not. Because what happens if you get to that step 4 or whatever, that final step, and you realize, oh no, you screwed up something all the way back in step 1. Well, now what? You've already spent $1 bajillion getting to this point. This is probably not the thing that you want to use if you're having a time scale of 20 years. Because, hey, here's years 5, here's year 10, here's year 15. A lot of stuff changes in the span of a year. This computer that I'm working on right now, technologically, is outdated. The average lifespan of technology is 3 years. So whatever you learn in school in your freshman year, by the time you're a senior, something is out of date. Something has a new revision. Something has been replaced. That's just the way of technology. So if you're using something that's a long time scale, probably not the best idea to use something like this. But this is also, in a sense, coding. You have, line 1 of your code, and then line 2 of your code. Then you have line 3 of your code, so on and so forth. The computer, this is how the computer reads your code. Line 1, line 2, line 3, line 4. It will always go from top to bottom in order, unless you tell it otherwise. And we'll be getting into situations of where you tell it otherwise in a moment in other videos. But I want to actually, before I delete that, question here. Is this probably the cheapest way you could do this? Probably, yeah, it's probably quite cheap, actually. It's simple. Everyone's on the same page. But if this is a team of multiple people, say you're making a video game, and you're doing, oh, we want to do all the art first, and then do coding, and then do this, and then do that. Well, what are the artists now doing? They're not part of the other next steps. So this is probably not really a good solution for a team project either. There's positives and negatives to each and every possible SDLC you could have. Now, I'm going to now just divide this grid in half here, like this, and then I'm going to divide the grid in half again, like so. And I want you to imagine that these 4 quadrants, and I'll try to even this out a bit here, are 4 different steps. So let's just say this over here is planning, and this over here is developing, and this over here is shipping, and this over here is reviewing. So I want you to imagine that these are 4 different quadrants. So now, think of your phone. Think of the applications on it. There's always an update for something, right? There's always something that updates. Or your computer. Hey, your computer has a new update. We're updating the operating system. We're adding some features. We're fixing some bugs. This is a process that essentially never ends. And that's what's known as the spiral. So if I can... you're not going to let me use the curve. Okay, well, you know what? I will scroll. Okay, scroll. And just... Okay, I'll just make a directional arrow. I want you to imagine here a curve, a spiral. And at, say, this line right here, at the bottom line, when it intersects over there, that's when a new version of your operating system comes out. And then it'll go around again. Yep, come on, let's just keep going. It'll go around again. And it'll go around again. And we'll wind up having a new version of our operating system pop out. And it'll keep going on and on and on forever and ever and ever. This is essentially the spiral model of Sdlc. So this line, this spiral line in the center, which of course is, kind of jagged and not really spirally, but you get the point, represents each and every update that happens. There's update 1. There's update 2. So they plan what they're going to do, they develop it, they ship it out, and then, it ships to stores, and they go and say, okay, what worked, what didn't, what do we want to add, what do we want to do this, let's plan it, let's develop it, let's ship it, now let's review, now let's plan it, let's develop it, let's ship it, let's review, let's plan it, let's develop it, let's ship it, let's review, and it keeps going on and on and on for over and over and over and over again. Now there are some benefits to an idea like this. Benefit number 1 would be you retain your audience. Every single time you get an update, how many people go back and say, oh, an update, let me go and play this again? How many times do you buy oh, hey, look, there's a DLC character for Mortal Kombat. Oh, let me buy the character. Oh, and hey, I haven't played Mortal Kombat in a couple of months. Let me play some more Mortal Kombat now. Well, that's why they do it. They do it because it retains attention. And they're able to, just introduce a new character every couple of months, and they get their fan base to jump back in after they've, lost interest. Mario Kart doing the same thing. Hey, here's a couple new tracks to play. So on and so forth. And yes, I just realized that they're both acronyms would be MK. Yeah, but anyway, it's a benefit. Now, what's a downfall? Well, the time to plan it, develop it, ship it, and review it, plan it, develop it, ship it, and review it, costs money. There's people that have to do these things. There's time, there's, electricity for all the components and everything. The building. The more time you're working on this one project, the more money this one project is going to cost. And it's going to go over and over and over and over again. So at some point in time, we have to ask ourselves the question, when does this roadmap end? The way it is right now, it never ends. which means it will always continually get bigger and bigger and bigger, get more expensive. At some point in time, it's going to be too expensive to maintain, and you're going to have to cut bait and run, and go and say, nope, we're done with this, now it's time to make a sequel. Now it's time to make something else. We can't just live off the one thing again, right now. And you'll see that happen every now and then with computers. Anyone who had a MacBook around the year 2010 probably remembers every single one of their programs having to be re-downloaded, because the PowerPC architecture was obsolete, and they got rid of it in an update. Like, the operating system flat out would not allow any single game or any single program that ran on PowerPC architecture. It was made obsolete. The same thing happened with Windows operating system at Windows 7, I believe? Whereas before they had code of Windows XP and Windows 98 and Windows 2000 and Windows 95 and all the other previous version of Windows, even dating back to DOS. And eventually Microsoft just said, hey, it's too much money, it's too much code, it's too much effort to be backwards compatible with every single possible thing that you could possibly have throughout the history of computers. This is our new starting off point. Everything is new. We're not worried about any of the previous code. And they started the spiral anew. You know, you'll even see this with PlayStation or whatnot, where it's like, hey, PlayStation 2 was backwards compatible with PlayStation 1. And PlayStation 3 was backwards compatible with PlayStation 2 and PlayStation 1. And then PlayStation 4 went, no, we're starting afresh. We can't have a $2,000 console to try and incorporate all the architectural components that are in the other previous systems. It's not going to be doable. So that's, a potential downfall, potential benefit, that sort of thing. And then, of course, I'm just going to bring this idea right now. What happens if you, and I used a cloud on purpose here, what happens if you have no idea what you're doing? If you were just going to say, hey, I'm going to make something, and you don't know what it is you're going to make. Well, you're essentially brainstorming, and that's generally what's known as the Big Bang model. So I want you to imagine that each and every one of these little dots that I'm putting out here is essentially a new idea. And those new ideas, if you think about it, are costing time, are costing money. Wow, how did you swing all the way around there? There we go. They're costing time, they're costing money, and all that sort of stuff. But however many ideas you have, however many resources you have, determines how big this cloud can get. How much manpower you have, how much time you have, how much resources you have. That determines that sort of stuff. But eventually, and I do mean eventually, you'll have some sort of idea where it's like, hey, you know what? Let's come together. We're going to come together at a certain point of time, and we're all going to correlate. Let me just make these guys over here. We're all just going to coexist and bring together our ideas all into one place. And we're going to formulate ourselves a game plan. And maybe you'll find that, maybe those 4 ideas work for that idea. And these 3 ideas over here work best over on a different idea. And, this idea over here is, it's by itself. It's got 2 things. But, those 2 things work very well together. Excuse me, that's not what I clicked. Oh, I see why, because that's actually a dot over there that was already used. Whoopsie. So you might wind up having, different ideas that wind up coalescing together. You might have one, you might have multiple ideas. And those multiple ideas you could use for future projects, keep them on the back burner. But eventually, everything's going to coalesce around one idea. And then that idea is then going to ship out, so on and so forth. And that's essentially the Big Bang Theory, or the Big Bang Theory model when it comes to Sdlc. The actual Big Bang Theory is, completely different class. It's also a science, but it's not computer science. And it's not necessarily involved with coding. But that's basically an idea. So when would you use something like this? Well, when you have a nondescript, something or other. Like, say you're trying to start a business and you're going, well, we don't know who our audience is. We don't know what type of product we want to make. You could basically do something like this. Now, depending on how big this brainstorming session is, you might be using a lot of time, a lot of money, a lot of research. Or this could be very small. This could be, a couple-week process. Hey, we have a group project. I'm going to put you in groups of 4. You guys go meet together, come back to me in a week, tell me what you're going to do. And then for the next week, I want you to design what you said you're going to make. That could be a very small process like that. The thing is, we've got different processes for different types of scenarios. They each have their pros and cons, their benefits and whatnot. And there's others that I haven't gotten to. I mean, there's the Agile model, there's the V model, there's, parallel models. There's all sorts of models. Point being, there's not one model that fits all. But get us in the thought process of what exactly a process is. Because there's processes we use in coding. Remember how I said earlier in this video that coding goes line 1, line 2, line 3, it goes in order unless we tell it otherwise? Well, in the next video, I will give an example of let's go with the otherwise. You guys have a great day. See you in the next video.